This video is on inverse functions graphically. We're going to be looking at the inverse of functions, and we're going to be looking at the graphs of them instead of trying to find the equation and determine the inverse of it. So the first thing we want to look at is to see what happens if we have inverses. So if we look at this first part up here, we have an equation, f of x equals 6x minus 4, and then we have the equation g of x is equal to x plus 4 over 6. These are inverse equations of each other. So if I don't know the equation and I know coordinates instead, I can still look to see if they're inverses. So what we want to do is we want to fill in this table. So when x's are negative 2, when we have the x values, we plug them in to get the y values. 6 times negative 2 minus 4 is negative 16. 6 times negative 1 minus 4 is negative 10. 6 times 0 minus 4 is negative 4. 6 times 1 minus 4 is 2. And 6 times 2 minus 4 is 8. So we have our x's and our y's. Now if I move over to the inverse, I'm going to plug in some numbers. We're going to put in the negative 16. So negative 16 plus 4 divided by 6 is going to be negative 2. Negative 10 plus 4 divided by a positive 6 is negative 1. Negative 4 plus 4 divided by 6 is 0. 2 plus 4 divided by 6 is 1. 8 plus 4 divided by 6 is 2. Now, what do we notice? So what did we notice? If you look at your x's and your y's, these x values are the exact same as these y values. The f of x y values are actually the same as the g of x values. So if we take these two columns and just take all the numbers in these two columns and flip them, we have the exact same table over here. So really, the x and y values are just switched. They're flipped. They're not changed in signs. They are actually flipped. So the x and y values switched. They flipped. Now, to understand what is really happening, you have to understand what inverses are doing. If you are going to have an inverse, there's a reflection over the line y equals x. The reflection over the line y equals x is the inverse. It has the mapping rule of xy maps to yx, which is why the x and y values have actually just flipped. You've taken the x's and put them in the y's. You've taken the y's and put them in the x location. That is what's happening. It's reflecting over that line y equals x. So when we graph them, we could actually connect the coordinates and see that they will, that y equals x will go through the middle of the connecting of them, if I were to connect the coordinates. So what is the purpose of inverses? Inverses are undoing functions. Inverses are undoing operations. You do an inverse of addition is subtraction. The inverse of multiplication is division. You undo something. So the purpose of inverses is to undo a function. So again, you might have heard, so if you know what PEMDAS is, that's order of operation. To undo that, you would do SADMAP. So when you're solving, if it's subtraction, you would want to add it to the other side because you would be undoing the subtraction. It's the inverse operation. The inverse operation of division is multiplication. Multiplication is division. So you are undoing by using inverses. An important note, we want to recall that to determine if it's a function, because we're going to be dealing with functions, if a graph passes something, then the graph is a function. A graph has to pass a vertical line test. The graph has to pass the vertical line test. But the important part of that is that it is in fact the graph. That's the original graph. So if a graph passes the vertical line test, then that graph itself is a function. That means that it is a function, nothing else. But the new thing we're going to be talking about, if we still are using the same graph, the original graph, it passed the vertical line test, and that graph is a function. But if the original graph passes something else, then we'll automatically know that the inverses graph is a function. So we're going to talk about the original graph. If the original graph passes something, then the inverses graph is a function. So what's the inverse of a vertical line? If we still are going to be using the original graph, but instead of looking at the vertical line, we're going to look at the horizontal line test. So if the original graph can pass the horizontal line test, then we already know that the inverse will be a function. We do not have to have the graph of the inverse to determine if it is a function. If we already know that the original will pass the horizontal line test, then the inverse will in fact be a function. So we can determine that ahead of time.